Hi, my name is Steve Francis. Welcome to this high-level overview of LogicMonitor and the problems we're trying to solve. In a standard data center, you typically have networking gear from Cisco or Juniper or F5. You have servers from IBM or Dell or HP, virtualization technology from Amazon or VMware or possibly Citrix Zen Server. You get databases from Oracle, MySQL, SQL Server, Postgres, applications such as Tomcat applications, other Java applications, IIS, Nginx, and so forth. Storage from NetApp, EqualLogic, and other vendors. The way many customers try and monitor this infrastructure is they end up buying a monitoring system from whoever they got their infrastructure from. So they may possibly have two network monitoring systems, one from Juniper for firewalls, one from Cisco for routing and switching. They may have a separate monitoring system from HP for their server hardware, other monitoring systems from relying on Amazon and from Oracle and Microsoft System Center and NetApp. Of course, problems with this is you end up needing infrastructure for all these monitoring systems. Often you require 2 or 3 servers for each monitoring system, web front end, database back end, and so forth, a collector. And then of course you often have backup issues and failover and fault tolerance issues. So you may end up with 20 to 30 servers that you have to maintain just to monitor your infrastructure before your business even adds any value or provides any services. You've got 30 servers to maintain. That's quite a lot of overhead. But of course the bigger problem with this is that separate monitoring systems means the information is siloed. So if you're the database administrator, you may see on your database monitoring tool that there's some performance issues. You will not be able to see that the performance issue is due to the fact that your database server has been virtualized, is running on an ESXi server. The ESXi server is getting its data store from a NetApp. The NetApp happens to be serving another volume to a QA server on the same aggregate as the data store for the ESXi server, and the QA server is suddenly doing a load test, and so all of a sudden you've exceeded the I/O capacity of that aggregate on your storage array. It's increasing latency, it's overloading the ESXi servers, and it's made your database go slow. The database admin has no way of seeing what's going on. All he knows is it's slow. He's going to have to work with different groups, try and find people to give him access to the other monitoring or have them investigate the issue. That obviously slows time to resolution, makes outages longer, performance issues more impactful, and costs more staff time. So the way LogicMonitor addresses this is you have the same infrastructure in your data center. Instead of having separate monitoring systems, you deploy a single LogicMonitor collector. Let me point out this is not a physical piece of hardware. It's a Java application, can be run on any server, Windows, Linux, can be run on virtual servers, and commonly is. It's just pointed out here as a separate box for clarity, but it's just a Java application, no configuration to put on it. The collector, once it's installed, which is all you have to do, no configuration, has embedded knowledge of how to talk to all the infrastructure in a data center, whether it's SNMP to networking gear, IPMI or WMI or perfmon or SNMP to servers. It integrates with the Amazon API, the VMware API, the Zen Server API, talks natively to Oracle, MySQL, SQL Server, Postgres, and so forth. Can speak JMX, can JSON, XML, talks to a wide variety of applications, and is integrated with a variety of storage equipment vendors, be they NetApp or EqualLogic or Data Domain and so forth. All the data is encrypted. It's collected on the collector and then posted out through an encrypted SSL channel to the LogicMonitor data center. So typically no firewall changes are needed. Once it's in the LogicMonitor data center, it's stored, it's trended, it's available for displaying dashboards and long-term graphs, and it's assessed against any alert thresholds. And then the alerts are sent out from the LogicMonitor data center. That fact in itself is significant because it means if you lose a data center, or if you're running in the cloud, if Amazon has a power outage, such as they did last night, or they have another server reboot, if your monitoring is in the data center, whether that's a physical or cloud-based data center, and that data center has an issue, your monitoring is not going to tell you because it's down too. So having your monitoring outside any of your data centers, physical or virtual, is always a good idea, because then the alerts come from outside your data center and can alert you to issues. They also let you see immediately what has failed over to another data center and what hasn't if you're in that kind of situation. And of course the other big benefit is all your business users can now access the same data from the same portal, which means your DBA can now immediately see that the root cause of his performance slowdown is the overloaded storage system, and that is being caused by a QA volume, so then he can go remediate that issue much quicker. So the gains that LogicMonitor gives you are several. Obviously, one of them is the ability to see the entire IT infrastructure in a single place. Big advantages in that, not only in the efficiency of the equipment and the fact that it's accessible from anywhere, but also the fact that less people work together and you don't have anywhere near as much efficient systems to maintain. It's not uncommon for us to reduce monitoring from 10 systems down to 1. LogicMonitor is unique in that it supports all the deployment paradigms. LogicMonitor is only delivered as SaaS, but the infrastructure that it monitors can be SaaS-based, can be premise-based, can be multiple data centers, single data centers. It can be deployed with an agent on every server, or as we recommend, just a collector that monitors the data center, possibly another one for failover. We don't care if you use most of your infrastructure in your data center and then use the cloud for bursting. We will roll that up and present it in a single place. It's very flexible, very useful for SaaS companies and managed service providers. The short version of what LogicMonitor does is we like to say we give you better monitoring with less work. We do default to monitoring everything, and so we give you a whole lot of metrics, which really does let you dig in and really does reduce the time to resolution of performance issues. And we display the information in context. And we really are very open and extensible. We have a powerful platform. It's very easy to integrate with provisioning systems and Puppet and write-scale scripts and so forth. And very easy to extend to collect non-IT data. Another example of that is a managed service provider in Florida that's a customer. They were having a half-hour meeting every day with 28 technicians and the service manager. Instead, they instrumented their workflow ticketing system queues with LogicMonitor, gave the service manager better and real-time visibility into the queues and what was backing up and what needed attention, while simultaneously freeing up 14 man-hours every single day of time that could now be used for generating revenue in billable hours. So really, we let people scale their operations without scaling their staff costs. Two ways we do that. We let you monitor a whole lot more systems without putting any time on the monitoring. It's not uncommon for us to free up a full-time employee that was dedicated to monitoring and was the, quote, monitoring guy. And in exchange, we let everyone configure the monitoring through an easy web interface, and it takes very little time because they don't need the knowledge of how to set up the monitoring. The other advantage is the monitoring has a lot of embedded intelligence in it, so it lets less experienced staff act as if they're more experienced staff. If they, for instance, are setting up a Citrix NetScaler load balancer and they set up a system without redundancy, they'll get alerted about that. If there's issues with the system not synchronizing its configuration between the two, they get alerted about that, so they can actually learn and be empowered by the monitoring itself.